Hello, ladies and gentlemen. We're going to do a real quick quiz over some rational functions and also a little bit of factoring review. So if I give you a rational function in this form, it's important you realize it's like every other function. X plus 2 is like x minus h. Sometimes we'll write it like this. So this moves it like every other function. On the inside, x minus h, x plus 2 moves it actually to the left 2. So left 2, that's the vertical asymptote, and we'll say x equals -2. And also down 3, so down 3, that's my horizontal asymptote, -3 is right there. So these are asymptotes, we usually draw them as dashed lines, so something like that. The horizontal asymptote is y equals -3. When we draw this now, what we need to do is make a table, and we need to make a table sort of based around the vertical asymptote. So the vertical asymptote is -2, and if you plug -2 in, that's undefined. So this is just to help us sort of frame this thing out. We're going to go to the left one, that's -3, and to the right one, -1. And we're going to see what happens on either side of this vertical asymptote. If you plug in -3, you will have 1 divided by -1 minus 3. Well, that's -1 minus 3, so that's -4. -3 is at -4. And if I plug in -1 and do the same thing, -1 plus 2 is 1, so 1 over 1 minus 3, 1 minus 3 is -2. That puts us here. This helps us sort of see in which parts of the graph we're in based on our asymptotes, but we're kind of laid out now. Based on these asymptotes, it has to do this, and it has to do that, and then I just have to draw it and say, well, that's one part of the function. And down here in the bottom left, it's going to do the same thing. It has to do this. It has to do that. I just got to connect them. And there we go. These asymptotes define the end behavior. So they're telling us how this thing's going to look. At the end, we just have to figure out what happens here along the intersection of the asymptotes. Now to talk domain, we're going to say, well, there's kind of two parts. This guy goes from -infinity to, and then you have to pick up your pencil at the vertical asymptote, -2. That's sort of describing the first one. But we also have this guy, so we say union, and we start at -2, and this thing goes forever to the right. It starts at -2 and goes forever to the right. It doesn't ever actually hit -2, so we use parentheses. Similarly, the range is pretty much doing the same thing. This guy goes forever down, so -infinity to, but you have to pick up your pencil at the horizontal asymptote, which is -3, and then you do the same thing for the top half, -3 to infinity for this guy. Okay, so that's the first one. I'll go a little quicker for the second one now. The second one says x minus 3, so I know my vertical asymptote is 3, and plus 2, so my horizontal asymptote is 2. I'm going to draw those. 1, 2, 3, 1, 2. Now I'll make them dashed. Okay, let's make a table. We're going to put 3 in the middle. Again, that's undefined because 3 minus 3 is 0, and you can't divide by 0. 1 to the left of 3 is 2. 1 to the right of 3 is 4. Now I plug that in. 2. -1 over 2 minus 3 is also -1. So -1 divided by -1 is +1. 1 plus 2 is 3. 2, 3 puts us right here. Now I'm going to do the same thing with +4. So when I plug in 4, I get -1 over +1. So that's -1. -1 plus 2 is 1. So 4 is at 1. So a little bit different look to it, but the end behavior is going to be the same. So when I draw it, I'm going to say, all right, this thing goes forever to the right, forever down, forever up, forever left, a little closer to the asymptote. There you go. And you just got to kind of connect all these pieces. So it looks like this and like this. Domain, -infinity to the vertical asymptote, which is at 3, 3 to infinity. Range, -infinity to the horizontal asymptote, 2 to infinity. So -3 or -infinity to 3, pick up your pencil, 3 to infinity. -infinity to 2, pick up your pencil, 2 to infinity. That's your graphing. What else you got? Oh, well, can we work backwards? So if it looks like this normally, I'm going to now say, well, if the vertical asymptote is at 2, that means it went right 2. So to move it right 2, x minus 2. Horizontal asymptote's at -3, so down 3 puts us at -3. That's one that works. Really, this number could be anything. Just don't put an x in there. That might mess with you. That really could be anything, though. Now we're going to do some factoring and a little bit of polynomial expansion. This is basically just distributive property. So 5x squared plus 15x minus x minus 3. That's 5x squared plus 14x. When you combine like terms, that makes 14. Similarly, when you do these problems, my suggestion is leave the 2 alone. So x squared minus 3x plus 3x minus 9. Those cancel out, and you have x squared minus 9. Oh, that's dots. Okay, this is either conjugates, so this is dots when it's expanded. Then worry about the 2. 2x squared minus 18. There you go. So there's the expansion. That's just distributive property. Now we're going to go backwards, and we're going to factor. So if it says factor, what you need to do is recognize that there's different options. If it's got 2 terms, this is dots. So this is kind of like the one we just did. You take the square root of each term. The square root of x squared is x. The square root of 16 is 4. And since this is a minus sign, we need a positive times a negative. And what happens when you expand it out is the middle cancels out, just like right here. The middle will cancel out if you FOIL it out. So you have x squared plus 4x minus 4x, those go away, minus 16. That's factor completely. That's called dots. If you have a trinomial, you need to do split the middle. So I'll do 1 times 10, which is 10. This is 1 times 10, which is 10. I need numbers that multiply to 10, and they have to add to the middle. The middle is negative 11. So x squared and 10 don't change, but the numbers that multiply to 10 and add to negative 11 are negative 10 and negative 1. Then you factor by grouping. So you find the GCF of each half. The GCF of the first half is x, and you're left with x minus 10. It's a minus sign, so bring down a minus sign. 1 and 10 don't have anything but 1 in common, so it's just going to be x minus 10 because we factored out a negative 1. 10 divided by negative 1 is negative 10 because the negative times the negative is a positive. Then last step, we got to write them as factors, x minus 10 and x minus 1. That's factored completely. 2 more just like that, but these have leading coefficients. So we need numbers here that multiply to 6 times negative 5, which is negative 30, and add to 13. If it helps, make a table, 1 and 30, 2 and 15. Wait a minute, one of these has to be negative, so right there, that makes 13. So when I split the middle, 6x squared minus 2x plus 15x minus 5. Factor by grouping, 2x, 3x minus 1, plus these guys are both multiples of 5. Now I have 2 factors that look the same, 3x minus 1, and my other factor is 2x plus 5. One more, 2 times negative 1 is negative 2, so I need numbers that multiply to negative 2 and add to 1. 2x squared, what does that? Multiply to negative, how about 2x and negative 1x? So I split the middle, now I factor by grouping, x plus 1 minus 1, x plus 1. And here I get 2x minus 1, x plus 1, and that's factored. Okay? So short and sweet, you need to be able to graph, and you need to review factoring, something you guys have done for a long time. Good luck on your quiz, and that's all we got.